morning, my YouTube viewers. In this particular video, what we're going to discuss is how to forecast inflation rates using statsmodels ARIMA model. And if you remember from my previous video, ARIMA is a combination of autoregressive, differencing, and moving average models to make a forecast. So what we're going to do is we're going to write a program in Python to forecast inflation rates. And in order to write that program in Python, we have to import 4 different libraries that enables the program to run once you execute it. So the first thing we're going to do is we're going to import NumPy as NP, which is the numeric library, and it also creates NumPy arrays. And then we're going to import pandas as PD, which is the data processing library, and it also creates data frames and series. And then we're going to import matplotlib.pyplot as PLT, which is the visualization library. And from statsmodels.tsa.arima model, import ARIMA. So statsmodels is Python's statistical library. TSA is the time series module within the library. ARIMA model is the module within the TSA library, and ARIMA is the actual function that we're going to be using. And then so what we're going to want to do is we're going to want to generate some synthetic inflation data. So the first thing we're going to do is we're going to set our seed. So the reason why you set your seed is so every time you run the program, it initializes to the same values. So you do that by typing in np.random.seed, and you can type any number you want into the brackets. Then we define our variable months, which is pd.dateRange, brackets start equals 2018-01, comma, periods equals 60, so it's inflation for 5 years, and frequency equals M, so it's 5 years of monthly data. Then we're going to set the trend equals np.linespace, brackets 2, 6, len months, and so that's going to be 60. So that's a gradual increase in inflation rate. We're going to define the seasonality equals 0.5 times np.sine, brackets 2 times np.pi times months, month, divided by 12. And so that's your seasonal fluctuation. And we're going to define the noise equals np.random.normal. Normal is a normal distribution, bracket 0, 0.2, len months. So that's random noise that they've injected into the signal. And so your inflation rate equals trend plus seasonality plus noise. We're going to create a data frame using pandas. So inflation df equals pd data frame, brackets, curly brackets, month, colon, months, comma, inflation rate, colon, inflation rate. So your month is your first column, and your inflation rate is your second column. And then what we're going to do is inflation df dot set index, brackets, month, comma, in place equals true. And so what that happens is you're going to take month and you're going to make the month column the index, and the inflation rate is going to be the first column now. So now we're going to split the data into training and test sets. So trained data equals inflation df, square brackets, inflation rate, square brackets, colon, 48. So 48 months are going to be the training date. And test data equals inflation df, square brackets, 48 colon. And that means the last 12 months are going to be for your testing data. So now we're going to define our model, which is the ARIMA model. So model equals ARIMA, brackets, trained data, comma, order equals 111. and model fit equals model dot fit. So we're going to forecast on the ARIMA, and forecast equals model fit dot forecast steps equals Lin test data. So it's going to have 12 steps. And forecast index equals test data dot index, and you're going to use the test data index for plotting. So now what we're going to do is we're going to plot the data onto a chart. So PLT using matplotlib. So PLT.figure brackets fig size equals 6,4. PLT.plot brackets inflation df.index, inflation df square inflation rate, label equals observed inflation rates, color equals blue, alpha equals 0.6, plt.plot, brackets forecast index, forecast, label, forecasted inflation rate, color equals orange, and line style equals dash, and plt dot. Now we're going to put a vertical line in the chart. So plt dot axv line brackets x equals train data dot index square brackets -1 and color equals gray, line style equals dash, label equals train test split. Now we're going to add labels, title, and a legend to the chart. So the title is inflation rate forecasting using ARIMA. X label equals date. Y label equals inflation rate. And then you get a legend and a grid. So we're going to plot it and we're going to show it. And this is the inflation rate using ARIMA. And then you'll notice if you watch my previous videos, then what you need to do is you need to calculate the PDQ. And then if you calculate the PDQ, then you'll probably get, well, a different forecast anyway. But in this particular program, the PDQ wasn't calculated. It just gave you a 111. But if you wanted it to be more accurate, you have to go through the code to calculate the PDQ, and you definitely would get a different forecast. But this is the inflation rate forecasting using ARIMA. And so your blue is your synthetically generated data. Your orange is your forecasted inflation rates, and your gray is your train test split. And this is synthetically produced inflation over a period of 5 years, and the last year is forecasted. So that concludes this particular video. The next video will also be a time series forecasting subject, so I hope that you decide to watch it.